Namaste, my dear students, my dear friends, and my YouTube channel subscribers. This is Viplava Reddy, Maths faculty for intermediate students. మీరు చూస్తున్నారు మై లైఫ్ మై విలేజ్ మ్యాన్ వర్సెస్ మ్యాథ్స్ యూట్యూబ్ ఛానల్. నా వీడియోస్ మీకు నచ్చినట్లయితే లైక్ చేయండి, కామెంట్ చేయండి, సబ్స్క్రైబ్ చేయడం మాత్రం మర్చిపోకండి. మై డియర్ స్టూడెంట్స్, still now we completed all LAQs problems from straight lines topic. Now in this class, I am going to explain some very important SAQs problems from straight lines topic. My dear students, please watch each video completely, practice those questions thoroughly, then only you are able to get more knowledge on those questions. My dear students, while watching my videos, please see the description box. In description box, I mentioned the questions what I explained in that video. If you know the solutions of those questions, you may skip the video. If you don't know solutions of the questions, you may watch the video completely. Then only you are able to get more knowledge without time wasting. Okay? Now let's start the today topic, that is straight lines SAQs. Now first question from straight lines SAQs, 4 marks problems. In this problem, transform the equation 3x plus 4y plus 12 equal to 0 into slope-intercept form, intercept form and normal form of a straight line. In this problem, we have to convert the given equation into 3 forms. Okay, first one is slope-intercept form, intercept form and normal form. We know that y is equal to mx. Y is equal to mx is the slope form of a straight line, only slope form. Y is equal to mx plus c is the slope intercept form. Slope intercept, here slope of a line, m for slope, c for y intercept, not x intercept, y intercept. Okay, y minus y1 is equal to m of x minus x1. This is slope point form of a straight line. Slope, m for slope, x1 y1 is the point, slope point form of a straight line. Y minus y1 is equal to y2 minus y1 by x2 minus x1 of x minus x1. This is 2-point form of a straight line. x1 y1 is the first point, x2 y2 is the second point. If you know 2 points on a straight line, by using 2 points we can find out the equation of the line passing through those 2 points. Okay, by using this formula, x by a plus y by b is equal to 1. This is intercept form of the straight line, intercept form of the straight line. A is the x-intercept, b for y-intercept. Okay, next, x into cos alpha plus y into sin alpha is equal to p. X into cos alpha plus y into sin alpha equal to p. This is the normal form of a straight line. In this equation, in this form, p for perpendicular distance from origin to given straight line. Here p for perpendicular distance from origin to straight line. That means mod c by under root of a square plus b square. In this equation, normal form, p for perpendicular distance from origin to a given straight line. Nothing but mod c by under root of a square plus b square. Alpha, what is the alpha here? Alpha for angle between normal and x-axis. For example, this is the line, given line, ax plus by plus c is equal to 0. Draw one perpendicular line from origin to given straight line. This is the normal line. Okay, angle between x-axis and normal perpendicular line is the alpha. In this equation, alpha for angle between normal and x-axis, not line and x-axis. This is not angle, this is not alpha, this is not the alpha. Okay, this is the alpha. Angle between perpendicular line and x-axis. Okay. Next, x minus x1 by cos theta equal to y minus y1 by sin theta. This is symmetric form of a straight line. Symmetric form of a straight line. From this symmetric form, we get x is equal to x1 plus r cos theta, comma y is equal to y1 plus r sin theta. Here r is the parameter. So this is the parametric equation of the straight line. Slope form, slope point, slope intercept form, slope point form, 2-point form, intercept form, normal form, symmetric form, and parametric equation of a straight line. What is the general equation of a straight line? Ax plus by plus c is equal to 0. This is the general equation of the straight line. Given equation in the form of ax plus by plus c is equal to 0. In this problem, we have to convert the given equation into slope intercept form. This one, slope intercept form is this one, and intercept form this one, and third one is normal form of a straight line. Okay, let's see the problem. Now solution of the problem. In this problem, what is the given equation? Given equation in the form of ax plus by plus c is equal to 0. That is equal to 3x plus 4y plus 12 equal to 0. First of all, what is the first form? You have to convert in the equation into slope intercept form. Slope intercept form. Slope intercept form of a straight line. What is the slope intercept form of a straight line? Y is equal to, we know that y is equal to mx plus c is the slope intercept form of a straight line. Now take the equation 3x plus 4y plus 12 equal to 0. Now LHS should be only y, single y only. In LHS only single y only. Remaining terms all remaining terms send right side. Okay. Equation 4y is equal to minus 3x and minus 12. Now dividing each term on both sides by 4. Okay. We get the single y. Okay. Y 4y by 4 means y minus 3 by 4 of x minus 12 by 4 means minus 3. Dividing each term by 4. Okay. It is in the form of y is equal to mx plus c. It is in the form of y is equal to mx plus c. Here in this form, what is the m for? M for slope. Slope of the given line. Slope m is equal to how much here? Slope minus 3 by 4 is the slope. Okay. Here C for y intercept, not x intercept, y intercept. Remember, C for y intercept. C for y intercept. How much here? Minus 3 is the y intercept. Now second form. What is the second form? Second form. This is the intercept form. Intercept form of a straight line. Intercept form of a straight line. What is the intercept form of a straight line? X by a plus y by b is equal to 1. X by a plus y by b equal to 1. RHS should be plus 1. RHS should be plus 1. Now take the given equation 3x plus 4y plus 12 equal to 0. First of all, send the constant term right side. From this equation, 3x plus 4y is equal to minus 12. How to get plus 1 on RHS side? How to get plus 1 on RHS side? by dividing each term by RHS, that is minus 12. Dividing each term by minus 12, we get the plus 1 on RHS side. Okay. Dividing each term by minus 12, that is 3x by minus 12 plus 4y by minus 12 equal to minus 12 by minus 12. From this above equation, we get x by minus 4 plus y by 4 ones are 4 3s are minus 3 is equal to plus 1. It is in the form of x by a plus y by b equal to 1. X by a plus y by b equal to 1. This is the intercept form of a straight line. From this above equation, what is the x-intercept? X-intercept small a equal to minus 4. Y-intercept small b equal to how much? Minus 3. Here x-intercept is minus 4, y-intercept is minus 3. Okay. Now third form. What is the third form of a straight line? You have to convert in the equation into third form, that is normal form. Normal form of a straight line. Normal form. What is the normal form of a straight line? We know that x cos alpha plus y sin alpha equal to p. X cos alpha plus y sin alpha equal to p. Here p for perpendicular distance from origin to straight line. From origin to perpendicular distance from origin to straight line, nothing but mod c by under root of a square plus b square. Already given question in the form of ax plus by plus c. C is there in the given equation. There is no under root of a square plus b square term. So for that, you have to dividing each term by under root of a square plus b square. First of all, find out take the given equation, that is 3x plus 4y plus 12 equal to 0. It is in the form of ax plus by plus c. Now first of all, find out the under root of a square plus b square value. What is the a square plus b square value? A for a means 3, square means 9, plus b means 4, square means 16, root 25, that is equal to 5. Now dividing each and every term by 5, we get the mod c by under root of a square plus b square. First of all, send the constant term right side. From this equation, we get 3x plus 4y equal to minus 12. But in the equation, p for perpendicular distance always positive. So RHS part should be positive in normal form. Okay, RHS constant term should be positive. That's why multiply with minus 1. Okay, multiply with minus 1, we get minus 3x minus 4y equal to plus 12. After getting positive term on right side, dividing each term by under root of a square plus b square. From this equation, dividing each term by under root of a square plus b square, that is minus 3x by what is the under root of a square plus b square value? 5. Okay, minus 3x by 5 minus 4y by 5 equal to 12 by 5. This can be written as x into minus 3 by 5 plus y into minus 4 by 5 equal to 12 by 5. This is in the form of x cos alpha plus y sin alpha equal to p. So compare this equation with x cos alpha plus y sin alpha equal to p. From this, by comparing this equation by normal form, we get cos alpha equal to minus 3 by 5, sin alpha equal to minus 4 by 5, and p is equal to 12 by 5. Okay, perpendicular distance how much here? 12 by 5. P is 12 by 5. cos alpha is equal to minus 3 by 5, sin alpha is equal to minus 4 by 5. From these two terms we get, from these two values, tan alpha is equal to sin alpha by cos alpha. Tan alpha is equal to sin alpha by cos alpha. Minus 4 by 5 by minus 3 by 5. That is equal to 4 by 3. 4 by 3. Here cos alpha negative, sin alpha also negative. Cos, sin both are negative. In which quadrant? Cos positive. First of all, cos positive in first quadrant and fourth quadrant. Cos positive in first quadrant and fourth quadrant. Cos negative in second quadrant and third quadrant. Cos negative in second and third. Sin positive in first quadrant and second quadrant. Sin positive in first and second. Sin negative in second, third and fourth. Third and fourth. So cos, sin both are negative. Both are negative. In which quadrant? Third quadrant. In third quadrant. Third quadrant starting from 180 degrees. Between 180 and 270 degrees. Between 180 and 270. Third quadrant nothing but between 180 degrees and 270 degrees. What is the starting value of third quadrant? 180 degrees. So from this equation, alpha is equal to pi plus tan inverse of 4 by 3. Why? Because alpha belongs to third quadrant. Here cos, sin both are negative. That's why add 180 degrees plus remaining angle. Okay. 180 plus remaining angle. That is tan inverse of 4 by 3. So this is the alpha value. This is the p value. X cos alpha plus y sin alpha is equal to p in this two variables. One is p and one is alpha. Alpha is equal to pi plus tan inverse of 4 by 3. P for perpendicular distance from origin to given line. That is 12 by 5. So this is the normal form of a given line. Okay. Intercept form, slope intercept form and normal form. Okay. Next. Now second question from straight lines SAQs. In this problem, a straight line through q root 3 comma 2 makes an angle pi by 6 with the positive direction of the x-axis if the straight line intersects the line root 3x minus 4y plus 8 equal to 0 at point P, then find the distance PQ. In this problem, we have to find out the distance between P and Q. This is the line passing through Q root 3 comma 2. This is the given point. One line is passing through Q root 3 comma 2 and making an angle pi by 6 with the positive direction of x-axis. For example, this is the x-axis, making an angle of pi by 6 with the positive direction of x-axis. Means positive direction of x-axis means anti-clockwise direction. Pi by 6 nothing but 30 degrees. Okay, 30 degrees. For example, this is the y-axis, this is the x-axis. Okay. Here inclination of this line is 30 degrees. And this line intersects the another line, that is root 3x minus 4y plus 8 is equal to 0 at point P. For example, this is the given line, that is root 3x minus 4y plus 8 equal to 0. This is the given straight line. This line intersects the given straight line at point P. Then you have to find out the distance between P and Q. Distance between P and Q. This can be solved in two different ways. By using parametric equation of a straight line concept, it will be easy. Okay. Apply parametric points on a straight line. We know that parametric points of a straight line. What is the parametric points on a straight line? X is equal to x1 plus or minus r cos theta. Y is equal to y1 plus or minus r sin theta. Given equation. What is the given equation? root 3 x minus 4y plus 8 equal to 0. Given point Q, root 3 comma 2. Given angle is theta is equal to pi by 6, that is equal to 30 degrees, 180 by 6. Okay. We know that on a line, each and every point in the form of x1 plus or minus r cos theta, comma y1 plus or minus r sin theta. This is the parametric points on a straight line. x1 plus or minus r cos theta, comma y1 plus or minus r sin theta. This is the parametric points on a straight line. Okay. Each and every point on a line in the form of x1 plus or minus r cos theta, comma y1 plus or minus r sin theta. Here r is the, what is the r? R for distance between P and Q. Here Q is the known point, P is unvariable point, unknown point. Okay. Distance between P and Q. Let distance between P and Q is equal to small r. Here Q is the given point, P is the unknown point. So the P is lies in the on this line. So let P also in the form of x1 plus or minus r cos theta, comma y1 plus or minus r sin theta. So here x1 y1 is the given point. This is x1 y1 point, and theta is the angle, given angle, inclination of this line. Okay, inclination of this line with x-axis, and r is the distance between PQ. You have to find out the r value here. Okay, you have to find out the r value. Now find out the coordinates of P. Find the coordinates of P. That is equal to P of x1 means root 3 plus, take plus case or minus case. Okay, any one case. R into cos 30 degrees. Cos of 30 degrees. Comma y1 means 2 plus r into sin 30 degrees, sin theta, sin 30 degrees. That is equal to P of root 3 plus cos 30 degrees. Cos 30 degrees is equal to how much? Root 3 by 2. So r into root 3 by 2, nothing but root 3 r by 2, comma 2 plus r into sin 30. Sin 30 value 1 by 2. So r into 1 by 2, nothing but r by 2. This is the coordinates of P. From the diagram, P is the point of intersection of this line and given line. Okay, point of intersection of two lines. Here P lies on the given line. From the diagram, from the given data, P lies on the given line also. Okay, since P lies on given line, that is P lies on root 3x minus 4y plus 8 equal to 0. Means if a point lies on a line, that should satisfy the given equation. Now replace the x coordinate in the place of x, y coordinate in the place of y. We get the r value. Now simplify this equation. Replace the x coordinate in the place of x, y coordinate in the place of y. In equation, given equation, that is equal to, that implies root 3 of x value, x coordinate how much in P? Root 3 plus root 3 r by 2 minus 4y. So minus 4 into y coordinate of P, 2 plus r by 2, 2 plus r by 2 plus 8 equal to 0. By simplifying this equation, we get r value. Root 3 into root 3, 3 plus root 3 into root 3 by 2 means 3 by 2 r. Okay, 3 by 2 r. Root 3 into root 3 by 2 means 3 r by 2. Minus 4 into 2 means minus 8. Minus 4 into plus 4 r by 2 means minus 4 r by 2 plus here 8 equal to 0. Now from this equation, here minus 8 plus 8 get cancelled. Remaining terms 3 plus 3r by 2 minus 4r by 2 means 3r minus 4r means minus r by 2 equal to 0. That implies 3 is equal to r by 2. From this equation, r is equal to 6. What is the r for? R means distance between P and Q. Therefore, distance between P and Q is equal to 6 units. Okay, 6 units. So, by using parametric concept of a straight line, x1 plus or minus r cos theta, y1 plus or minus r sin theta is the parametric points on a straight line. That means each and every point on the line in the form of x1 plus or minus r cos theta, comma y1 plus or minus sin theta. P also lies on this line. So P also in the form of x1 plus or minus r cos theta, comma y1 plus or minus r sin theta. So here given point treated as x1, y1, given angle of the inclination of this line is 30 degrees already given, that is the theta. R is here, distance between P and Q is the small r. Small r is the distance between P and Q. Okay, by using parametric concept it will be easy. Okay, now third problem from straight lines SAQs. In this problem, a straight line with slope 1 passes through q minus 3 comma 5 and meets the straight line x plus y minus 6 is equal to 0 at point P. Then find the distance PQ. In this problem also, we have to find out the distance between P and Q. Here slope of the line is m. Here given slope of the line, for example, m is equal to 1 is given already. Slope is equal to 1 means tan theta is equal to 1. So inclination of that line is equal to 45 degrees. That means, for example, this is the x-axis. The line passing through q minus 3 comma 5 and having slope 1. That means 45 degrees. Inclination of this line is 45 degrees. Okay, inclination of this line is 45 degrees. And this line and this line and this line meets the given line, that is x plus y minus 6 equal to 0 at point P. Then you have to find out the distance between P and Q. For example, this is L1 is equal to 0. This is the given line is L2 is equal to 0. This problem also can be solved in two different methods. By using parametric equation concept, and after second method is first of all find out the equation of L1. After finding the L1 equation, solve L1 and L2. We get the point of intersection P. After getting point P, find out the distance between P and Q by using distance formula under root of x1 minus x2 whole square plus y1 minus y2 whole square. How to get equation of L1? Already we know one point on L1, that is Q, given in the problem. Q is the point on the L1 line. Slope also given 1. By using slope point form, that is y minus y1 equal to m of x minus x1. By using this formula, we can get the equation of L1 equal to 0. After finding L1 equal to 0, solve equation L1 and L2. Solve these two equations, we get the point of intersection of L1 and L2, that is P. After getting P coordinates, apply distance formula under root of x1 minus x2 whole square plus y1 minus y2 whole square. This is the second method. So by using parametric concept, it will be easy. Okay. Now apply parametric concept. What is the parametric concept? Parametric points on a straight line, that is x1 plus or minus r cos theta, comma y1 plus or minus r sin theta. In this problem, given point Q minus 3 comma 5. This is the given point. Let us assume x1 y1. So on this line, each and every point in the form of parametric points, that is P x1 plus or minus r cos theta plus case y1 plus r sin theta. Take plus case or minus case. Let assume distance between P and Q is equal to small. From the diagram, distance between P and Q assume R, okay, smaller. Now apply formula. Find out the coordinates of P. Here what is the x1 y1? Given point is x1 y1 minus 3 plus. You have to find out the PQ distance, that is R. This is the unknown term, R into cos theta. Theta is 45 degrees here. Slope is equal to 1. Given slope is equal to 1 means tan theta is equal to 1. From this, theta is equal to 45 degrees. Inclination of this line L1. Inclination of L1 is 45 degrees. So cos 45 degrees, comma y1 means 5 plus R into sin theta means sin 45 degrees. Now simplify this. P of minus 3 plus cos 45 value 1 by root 2. R into 1 by root 2 means R by root 2, comma 5 plus R into sin 45 also 1 by root 2. So R by root 2. Here P, this is the coordinates of P. From the diagram, P is the point of intersection of L1 and L2 means P is the common point of L1 and L2 means P lies on second line also. Therefore, since P lies on L2 is equal to 0. L2 is nothing but given equation. P lies on x plus y minus 6 is equal to 0. Now simplify this equation, we get R value. In the place of x, replace x coordinate. In the place of y, replace y coordinate. So that implies in the place of x, x coordinate, that is minus 3 plus R by root 2 plus this one y coordinate, that is plus 5 plus R by root 2 minus 6, x coordinate plus y coordinate minus 6 equal to 0. Here R by root 2 plus R by root 2, that is 2R by root 2 minus 3 plus 5 plus 2 minus 6 plus 2 minus 6 means minus 4 equal to 0. From this equation, 2R is equal to 4 into root 2. From this equation, R is equal to 2 root 2 units. 2 root 2 units. What is the R for? R means distance between P and Q is the R. Distance between P and Q. Therefore, what is the distance value? Distance value how much here? PQ is equal to 2 root 2 units. Okay. By using parametric concept, by using general method, okay, we can solve this problem. Next, fourth problem from straight lines SAQs. In this problem, a straight line passing through a 1 comma minus 2 makes an angle tan inverse of 4 by 3 with the positive direction of the x-axis in the anti-clockwise sense. Then find the points on the straight line whose distance from A is 5. In this problem, we have to find out the points, coordinates of points. Those are 5 units away from the given point. For example, this is the line. On this line, one point is given, that is A 1 comma minus 2 is given point. Okay, you have to find out the points on this line. Those are 5 units away from the given point. For example, maybe upper side or maybe lower side. Maybe this is the one point possible. The distance between A and P is 5 units. Maybe lower side also one point is possible. That is distance between A and Q also maybe 5 units. There are 2 points are possible. Those are 5 units away from the given point 1 comma minus 2. In the problem, one more point is given, that is angle made by this line is tan inverse of 4 by 3. For example, given angle how much? Here given, let theta is equal to tan inverse of 4 by 3. Tan inverse of 4 by 3. Angle made by this line with positive direction of x-axis. With positive direction of x-axis is correct. Theta is the angle made by this line. And theta is equal to tan inverse of 4 by 3. We know inclination of the line, we know the one point. In that case, you have to find out the coordinates of P and Q. We know that one concept. On a line, each and every point in the form of x1 plus or minus r cos theta, comma y1 plus or minus r cos theta. By using parametric equation, parametric points concept, we can find out the coordinates of P and Q. What is the parametric equation? Parametric equation or parametric points. Parametric points means parametric coordinates of a points on a line. That is x1 plus or minus r cos theta, comma y1 plus or minus r sin theta. In this parametric equation of a equation or parametric points, in x1, y1 is the given point. That is a x1 y1 is equal to 1 comma minus 2. Given point is the x1 y1. Okay. Next, theta is tan inverse of 4 by 3. From this, tan theta is equal to how much? 4 by 3. From this, tan theta is equal to 4 by 3. Apply Pythagoras rule. For example, this is the right angle. Here, take theta here. This is 4, this is 3. From Pythagoras rule, this is equal to 5 units. From this, cos theta is equal to formula adjacent by hypotenuse. That is 3 by 5. Sin theta is equal to, from this triangle, sin theta is equal to 4 by 5, opposite by hypotenuse. We get the cos theta value and sin theta value. What is the r? R means given distance. This is the r. This is r. R is equal to 5 units. R is equal to 5 units. Here r is equal to 5 units. Okay. Given point, given distance. From the inclination, we get the cos theta value, sin theta value. x1 plus or minus r cos theta, y1 plus or minus r sin theta. We get the 2 points. By using plus case, by using minus case, we get the 2 coordinates of a points. Okay. That is equal to x1 means x1 comma y1. 1 plus or minus r means 5 into cos theta. Cos theta value how much here? 3 by 5. Comma y1 means minus 2. Plus or minus r means 5 units. Sin theta value 4 by 5. 4 by 5. Now apply plus case and minus case. By using plus case, that is equal to 1 plus 5 cancel 3. 1 plus 3 means 1 plus or minus 3, comma minus 2 plus or minus 5 cancel 4. Okay. Now apply plus case and minus case separately. Take plus case first of all. 1 plus 3, comma minus 2 plus 4. And take minus case. 1 minus 3, comma minus 2 minus 4. So from these above points, 4 comma plus 2 and minus 2 comma minus 6. This is the first point, this is the second point. There are 2 points are possible. Okay. Next, fifth problem from straight lines SAQs. In this problem, a straight line L is drawn through the point A 2, 1 such that its point of intersection with the straight line x plus y is equal to 9 is at a distance of 3 root 2 from point A. Then find the angle which the line L makes with the positive direction of the x-axis. Question number 2, 3, 4. Question number 2, 3, 4 and fifth problem also. All are by using parametric concept only. By using parametric concept only, these all problems are solved. Okay. By using parametric concept, it will be easy. In this problem, we have to find out the inclination of the line. Inclination with positive direction of x-axis. The angle made by the line with x-axis in anti-clockwise sense. Okay. That is the inclination of the line. In this problem, we have to find out the angle made by the line with positive direction of x-axis. Now, given point What is the given point? Given point is a 2 comma 1. Let us assume this is x1 y1. And what is the distance from given point to point of intersection? Let r is the distance, that is equal to 3 root 2. In this problem, for example, this is the line. This line is passing through one point A 2 comma 1. Passing through 2 comma 1. And the point of intersection of this line and given line, that is, for example, this is the another line, that is x plus y is equal to 9 line. This line, both are intersecting one point. For example, this is the point P. The distance from P, point of intersection of the distance from P, that is point of intersection of these two lines and given point is how much? 3 root 2. The point of intersection is 3 root 2 away from the given point. Okay, 3 root 2 away from the given point. And in that case, you have to find out the angle made by the line with positive direction of the x-axis. Means you have to find out the inclination of this line. Means angle made by this line with positive direction of x-axis. We know that parametric concept. What is the parametric points on a line? Each and every point in the form of x1 plus r minus r cos theta, comma y1 plus r minus r sin theta. By using plus case, we can find out the theta value. Okay. Here you have to find out the inclination of line. You have to find out the inclination of line. Means theta. What is the parametric points? Parametric points. Parametric point of a parametric point on a line. Okay. Parametric point on a line. That is x1 plus or minus r cos theta, take plus case, comma y1 plus or minus r sin theta. Here x1, y1 is the given point. R is the distance from given point to point of intersection. And theta is the inclination of this line. Okay, you have to find out the theta value. Okay, you have to find out the theta value. This is the coordinates of P. This is the coordinates of P. Why? Because on this line, each and every point in the form of x1 plus r cos theta, comma y1 plus r sin theta. P is a point of intersection of first line and second line. So P also lies on the first line. So P also in the form of x1 plus r cos theta, comma y1 plus r sin theta. Now apply, replace these values, we get the P coordinates. P of x1 means 2 plus r value 3 root 2. We don't know theta value, so cos theta, take as it is. Comma y1 means 1 plus r means 3 root 2 into sin theta. This is the coordinates of P. From the diagram, P lies on first equation as well as second equation, because P is the point of intersection of L1 and L2. Since P is the point of intersection of two lines, means P lies on second equation. That is, what is the second equation here? P lies on x plus y equal to 9. So replace the x in the place of x coordinate, in the place of y coordinate. From this equation, replace the x coordinate and y coordinate in the place of x and y. 2 plus 3 root 2 cos theta, x coordinate, plus what is the y coordinate? 1 plus 3 root 2 sin theta is equal to 9. Now solve this equation, we get the theta value. Here 2 plus 1, how much? 3. Same right side. That implies here 3 root 2, 3 root 2. Take common. 3 root 2 of cos theta plus sin theta is equal to how much? 9 minus 3, 6. From this equation, cos theta plus sin theta is equal to 6 by 3 root 2, means 2 by root 2, nothing but root 2. So dividing each and every term by root 2, we get that. Simplify this equation. Simplify sum of these two trigonometric ratios into single ratio. Okay. That's why converting, dividing by under root of a square plus b square. That is called under root of 1 square plus 1 square. That is equal root 2. Dividing each term by root 2, we get the single ratio term. Okay. That means cos theta plus sin theta by root 2 by root 2. Yeah, root 2 by root 2 means 1. Okay. This can be written as cos theta into 1 by root 2 plus sin theta into 1 by root 2 means cos theta into 1 by root 2. 1 by root 2 nothing but cos 45. Cos 45 degrees. 1 by root in the nothing but 1 by root 2 is nothing but cos 45 degrees. Here sin theta into 1 by root 2 means 1 by root 2 means here sin, in terms of sin 45, that is equal to 1. From this equation, cos A, it is in the form of cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B. What is the formula? Cos A cos B plus sin A sin B. Nothing but cos of A minus B. Cos of A means theta minus B means 45 degrees. That is equal to 1. 1 can be written as cos of 0 degrees. Cos theta minus 45 is equal to cos 0 degrees. So theta minus 45 degrees is equal to 0 degrees. From this, theta is equal to 45 degrees. Therefore, inclination of the line is 45 degrees. Okay. Next, sixth question from the straight lines SAQs. In this problem, transform the equation x by a plus y by b equal to 1 into normal form, and if the perpendicular distance of the line from the origin is p, then deduce that 1 by p square is equal to 1 by a square plus 1 by b square. In this problem, we have to transform the given equation into normal form. After that, prove that 1 by p square is equal to 1 by a square plus 1 by b square. Here p is the perpendicular distance from origin to given straight line. First of all, you have to convert the equation into normal form. What is the given equation in this problem? Given equation is x by a plus y by b equal to 1. Now simplify this equation. How to take LCM here? B into x bx plus a into y ay by ab. Ab is the LCM is equal to 1. From this equation, we get bx plus ay is equal to ab, or minus ab is equal to 0. Equal to AB into 1 means AB. Okay. Now converting this equation into normal form. What is the normal form? X cos alpha plus y sin alpha equal to P. In normal form, P for perpendicular distance from origin to given straight line. That is mod C by under root of a square plus b square. For that, first of all, find out the under root of a square plus b square value. Under root of a square plus b square value. Find the under root of a square plus b square value. A means coefficient of x. What is the coefficient of x in this problem? B. So b square plus b means coefficient of y. What is the coefficient of y here? A. So a square. Now dividing each and every term by under root of a square plus b square. Dividing the each term by under root of a square plus b square. We get the normal form equation. Okay. Now dividing by under root of b square plus a square is nothing but a square plus b square on both sides. Now from the above equation, bx by under root of a square plus b square plus second term ay by under root of a square plus b square is equal to constant here RHS part ab by under root of a square plus b square. What is the normal form? Normal form means nothing but x cos alpha plus y sin alpha equal to p. Okay. Now simplify this equation. This can be written as x into b by under root of a square plus b square plus y into a by under root of a square plus b square is equal to ab by under root of a square plus b square. So it is in the form of x cos alpha plus y sin alpha is equal to p. Nothing but normal form of a straight line. Now compare this equation and this equation. We get cos alpha is equal to coefficient of x is cos alpha is equal to b by under root of a square plus b square, and sin alpha is equal to coefficient of y, that is a by under root of a square plus b square. And what is the p value here? RHS part, that is nothing but in normal form p for perpendicular distance from origin to straight line given that is ab by under root of a square plus b square. Perpendicular distance always positive. Here already given a and b both are positive, so ab by some finite root is also positive. This is the normal form of the given line. Okay, this is the normal form of the given line. After converting the normal form, you have to prove that 1 by p square is equal to 1 by a square plus 1 by b square. Here p for perpendicular distance from origin to line. In this also p is nothing but perpendicular distance from origin to given straight line. Now consider this one. Take p is equal to ab by under root of a square plus b square. Now first of all squaring on both sides. We get p square value. P square is equal to a square b square by a square plus b square. Squaring on both sides. We get p square. A square b square by root cancel a square plus b square. Now rotate the terms. Okay, rotate the numerator, interchange the denominator and numerator on both sides. We get 1 by p square is equal to a square plus b square by a square into b square. Interchange the numerator and denominator. Okay. From this above equation, 1 by p square equal to split the denominator. First term by denominator plus second term by denominator. That is equal to a square by denominator plus b square by denominator. Okay. Split the denominator. We get the above statement, that is 1 by p square is equal to a square cancel, that is equal to 1 by b square. Here b square cancel, 1 by a square, nothing but 1 by a square plus 1 by b square. This is the sixth problem. Okay. Now seventh problem from straight lines SAQs. In this problem, line L has intercepts a and b on the axis of coordinates. When the axes are rotated to a given angle, keeping the origin fixed, the same line L has intercepts P and Q on the transformed axis. Then prove that 1 by a square plus 1 by b square is equal to 1 by p square plus 1 by q square. In this problem, intercepts are given before rotation, after rotation. Before rotation, after rotation. Before rotation, intercepts of the line are a comma b. after the rotation, intercepts are P comma Q. Okay. Now this is x-axis and this is y-axis. Okay. And this is the line L, given line. This given line L meets the x-axis at A and y-axis at B. From the given data, before rotation of axis, the distance between O origin and A is equal to small a, because this is x-intercept. OA is nothing but x-intercept of the line. OB is nothing but y-intercept of the given line L. Okay. In the given problem, when the axes are rotated through a given angle, keeping the origin fixed, without changing the position of the origin, rotate the coordinate axis, rotate the x-axis, either clockwise direction or anti-clockwise direction. I rotate the coordinate axis in clockwise direction with angle theta. Okay. For example, after rotation, the y-axis is like this. For example, this is the new y-axis. After rotation, this is the new y-axis. This is the x-axis. After rotation, this is the new x-axis, that is x dash. Here capital X, capital Y are the coordinate axis before rotation. Capital X dash, capital Y dash are the coordinate axis after rotation. After rotation, theta. Okay. Now, from the given data, after rotation, the same line L has intercepts P and Q. Means, for example, the same line L meets the new x-axis at capital P, new y-axis at capital Q. New x-axis at capital P, new y-axis at capital Q. In that case, what is the intercepts here? P and Q. That means the distance from O and P, nothing but new x-intercept. This is the new x-intercept. This distance is, this length is P, small p, new x-intercept. Distance from origin to Q, this is the new y-intercept. This is new y-intercept, that is small q. Okay. In that case, you have to prove that 1 by a square plus 1 by b square is equal to 1 by p square plus 1 by q square. Before rotation of axis, after rotation of axis, the position of the origin did not change, as well as the position of the line also. The position of the line also, this is the line. The position of the line also did not change. Only the direction of the x-axis and y-axis are changed. Only the direction of x-axis and y-axis are changed. Capital X changes to capital X dash. Capital Y changes to capital Y dash. Position of the origin before the rotation, after the rotation did not change, as well as position of the line also did not change. That means before the rotation, after the rotation, distance between origin and the line, distance between origin and line never changed. Never changed, because position of the origin, position of the given line are not changed. So distance between those point and line also did not change. Okay. So now apply that concept. What the concept here? Before rotation, distance from origin to line, that is, for example, d1 is equal to d2. d2 means after rotation, distance from origin to same line is equal. Okay. Now apply that concept. In these two cases, first case, in case 1, before rotation of axis, before rotation of axis, since A and B are the intercepts, since A and B are the intercepts of line L, therefore equation of the line. If you know the intercepts, if you know the two intercepts, how to find out the equation of the straight line? intercept form of a straight line, by using intercept form of a straight line. Equation of the line L is x by a plus y by b is equal to 1. X by a plus y by b is equal to 1. From this equation, simplify this equation, we get bx plus ay minus ab equal to 0. This is the equation 1. This is the equation of the line L before rotation of the axis. After rotation, in second case, after rotation of axis, after rotation of axis, P and Q are the intercepts of the line L equal to 0. So by using these two intercepts, therefore equation of the line is x by p plus y by q. X by p plus y by q is equal to 1. This is the equation of the line according to the old coordinate system. This is the equation of the same line according to the transformed coordinate system, new coordinate axis. Okay. From this equation, we get qx plus p into y, py minus pq is equal to 0. This is the equation of the same line after rotation the axis. What I am saying is, the position of the origin and the position of the line did not change before the axis and after the axis. The position of the origin, position of the given line did not change. So distance between origin and line also same in first case and in second case. Therefore, find the distance from origin to straight line in first case. Let D1 be the distance or perpendicular distance between O 0, and equation 1. Before rotation of axis, equation of the line is equation 1 is the equation of the line L. So D1 is the distance between origin and equation. What is the distance between one origin and distance formula? What is the distance formula? Distance from origin to a straight line, mod c by under root of a square plus b square. By using this formula, we will get the d1 value. Find out the d1 here. d1 is equal to mod c. What is the constant? Mod of minus ab, nothing but plus ab by under root of b square. A square plus b square is here b. Nothing but we get the a square plus b square. Okay. Now let d2 be the distance between origin 0, and equation 2. From the same formula, by using the same formula, d2 is equal to mod c. Here, what is the constant? Minus pq. Mod of minus pq means plus pq by under root of a square plus b square, nothing but p square plus q square. Before rotation of the axis and after rotation of the axis, position of the origin and position of the line did not change. So distance also never changed. Okay, in two cases distance never changed. Okay, so therefore d1 equal to d2. d1 equal to d2. In two cases distance are same. Okay, now d1 equating the d1 d2, ab by under root of a square plus b square equal to pq by under root of p square plus q square. Okay, now squaring on both sides, we get a square b square by a square plus b square is equal to p square q square by p square plus q square. Interchange the numerator and denominator. Rotate the fraction. Rotate the fraction. We get a square plus b square by a square into b square is equal to p square plus q square by p square into q square. Split the denominator, we get 1 by a square plus 1 by b square is equal to 1 by p square plus 1 by q square. Split the denominator. First term by denominator plus second term by denominator. First term by denominator plus second term by denominator. We get the relation between a, b, p, q. Okay. Now, 8th problem from straight lines SAQs. In this problem, find the locus of the foot of the perpendicular from the origin to a variable straight line which always passes through a fixed point a comma b. In this problem, we have to find out the locus of the foot of the perpendicular. Locus of the foot of the perpendicular of from origin to a variable line. For example, this is the variable line. We don't know the equation of the variable line. That's why let assume L is equal 0 is the variable line. This line always passes through a fixed point. That's why let a comma b is the one point, fixed point on the variable line. For example, this is the origin 0 comma 0. Draw one perpendicular line from origin to variable line. This perpendicular line meets the variable line at p x1 y1. For example, the point p is the foot of the perpendicular from origin to a straight line. So you have to find out the locus of this point. You have to find out the locus of the foot of the perpendicular. Here p is the foot of the perpendicular from origin to a line. So you have to find out the locus of p. Okay. Let here p is the point of locus. Okay. Let p x1 y1 be the point on the locus. From the diagram, line segment OP is perpendicular to line AP. The line segment OP is perpendicular to variable line AP. Why? Here OP, here P is the foot of the perpendicular, means the line joining O and P should be perpendicular to line. Okay. From the diagram, OP, line segment OP is perpendicular to a variable line, nothing but AP. OP is perpendicular to AP, line AP, variable line AP. If two lines are perpendicular, what is the condition? Their product of their slopes is equal to -1. If two lines are perpendicular, product of their slopes is equal to -1. That means slope of OP into slope of AP is equal to -1. Slope of OP into slope of AP is equal to -1. What is the slope of OP? First point, second point. This is first point, this is second point. Slope formula y2 minus y1 by x2 minus x1. y2 minus y1 by x2 minus x1. Apply formula y2 minus y1 by x2 minus x1. That is y1 minus 0 by x1 minus 0. This is slope of OP. What is the slope of AP? Slope of AP. This is the first point, this is the second point. Or this is the second point, this is the first point. y2 minus y1. B minus y1 by x2 minus x1. A minus x1 is equal to -1. By simplifying this equation, we get the locus of point P. From this equation, y1 into this one means y1 into b minus y1 by x1 into this one, means x1 into a minus x1 is equal to minus 1. Now from this above equation, y1 into b minus y1 is equal to minus of x1 into a minus x1. Now multiply inside y1 into b. y1 into b means b y1. y1 into y1 means y1 square equal to minus x1 into means minus a x1 minus into minus plus x1 square. Now send these all terms right side. We get x1 square plus y1 square minus ax1 minus by1 equal to 0. Therefore, this is the equation in terms of x1, y1. So, this is the equation of the locus of point P. Therefore, equation of the locus is x square plus y square minus ax minus by equal to 0. Locus of point P is x square plus y square minus ax minus by is equal to 0. It is in the form of x square plus y square plus 2gx plus 2fy plus c is equal to 0. So this represents circle. Okay, this represents circle. This equation represents circle. Okay, x square plus y square minus ax minus by equal to 0 represents a circle. So what is the locus of this point? Locus of P is circle. Okay. Now, ninth problem from straight lines SAQs. In this problem, let PS be the median of the triangle with vertices P, Q, R. Then find the equation of the straight line passing through 1, minus 1 and parallel to the median PS. In this problem, we have to find out a line equation. That line is passing through 1, minus 1 and parallel to the median PS. How to find out equation of a straight line? 1 point, 1 slope. Already 1 point is known, given in the question. And 1 int is given, that is the required line is parallel to median PS, median PS. If two lines are parallel, the required line and median PS are both are parallel, already mentioned in the question. If two lines are parallel, what is the condition? Slopes are equal. If two lines are parallel, slopes are equal. If two lines are perpendicular, product of their slopes is equal to minus 1. So in this problem, first of all find out the slope of median PS. Okay. What is the median? What is the median? For example, this is triangle PQR. This is vertex P and this is vertex Q and this one is vertex R. Okay. Already P is given 2, 2 given and 6, minus 1 is the vertex Q and 7, 3 is the third vertex. Median is nothing but the line joining vertex and midpoint of opposite side. For example, here S is the midpoint of QR. S is the midpoint of QR. Join line. The line joining the P and midpoint of opposite side. The line joining the P vertex and midpoint of opposite side is median of the triangle. Median of the triangle. Okay. Our required line passing through one point and parallel to median PS, means slope of the median PS is equal to slope of the required line. Slope of the median PS is equal to slope of the required line. First of all, find out the slope of the median PS. How to get slope of the PS? How to get slope of the median PS? Already P, we know P coordinates, okay? Find the S coordinate. Here S is the midpoint of QR. So by using midpoint formula we get the S coordinates. After getting S coordinates, y2 minus y1 by x2 minus x1 formula, by using that formula we get the slope of PS. Let S be the midpoint. S be the midpoint of QR. Midpoint of QR. Okay. What is the midpoint formula? Midpoint formula we know x1 plus x2 by 2 comma y1 plus y2 by 2. This is the midpoint formula. By using this formula we get coordinates of S. This is the first point, this is the second point. x1 plus x2 means 6 plus 7 by 2 comma y1 plus y2 minus 1 plus 3 by 2. From these above values we get 6 plus 7 13 by 2 comma plus 2 by 2, that is plus 1. This is the coordinates of S, midpoint of PQ. Now find out the slope of PQ. In order to find out the equation of PQ, if two lines are parallel, slopes are equal. No need to find out the equation of PS. Okay, no need to find out the equation of PS. Just find the slope of PS. Slope of median PS. Slope of median PS. That is equal to M is equal. What is the formula? Slope formula y2 minus y1 by x2 minus x1. First point, this is the second point, or this is the first point, that is the second point. y2 minus y1, y2 minus y1, that is equal to, M is equal to 2 minus 1 by x2 minus x1, 2 minus 13 by 2, that is 13 by 2. From this, M is equal to 1, 2 minus 1 is 1 by 4 minus 13, 4 minus 13 by 2. From this equation, from this value, 2 by minus 2 by 9, minus 2 by 4 minus 13, minus 9. So 2 by minus 9. Slope of the median is minus 2 by 9. So slope of the median is minus 2 by 9. This line is parallel to this line. Means required line is parallel to median PS. Therefore, since the required line is parallel to median PS, therefore slope of required line is nothing but slope of required line is equal to slope of the median, that is minus 2 by 9. By using this slope and this point, we get the equation of the required line. Therefore equation of the required line, by using point to slope point, by using slope point form of a straight line. What is the slope point form of a straight line? Y minus y1 is equal to m of x minus x1. From this, y minus y1 is here minus 1, minus of minus means plus 1. Slope m is equal to minus 2 by 9 into x minus x1 is plus 1. From this equation, 9 into y, 9y plus 9 into 1, 9 equal to minus 2 into x, minus 2x, minus into minus plus 2. Now take these terms left side, plus 2x plus 9y, here plus 9 minus 2 means plus 7 equal to 0. This is the equation of the required line. Okay. First to find out the midpoint of QR. After getting midpoint, find out the slope of median PS. We get the slope of PS. Next, find out the equation of the required line by using this slope and the given point. Okay, my dear students, please solve these questions and send your answers in my comment box. This is my today's maths challenge. Okay.